All right, here we go. Let's see if we can get rolling here. Okay, so 10.3. So now we're going to add a little bit more to our trinomials. So the homework we've just done had trinomials, and we're looking for that nice, correct middle term when we do outers and inners. And now we're going to make them just a little bit more complicated. So you don't need to put this in your notes. I'm just trying to focus your thought. The front term may have a coefficient. It might have a number multiplied it, like this example has a 6. And not only that, the back may have a squared term, although we did a few of those yesterday. So that's the difference. Really, the big difference is the front term having more than just a squared term. And that's going to change things up. All right, so 10.3, where A, B, and C are constants, which means they're just numbers, right? A, B, and C are numbers. You can put numbers if you want. So the big key here in this kind is that front number makes things a little different. The method of factoring trinomials is called, class, trial and error. Again, is it any big deal that you know the name? No, except for the fact that it triggers your brain on the method that you're using to solve it. And so that's where the value is. It's going to trigger your brain concerning the method that you're going to use to solve it, right? That's the idea. That's really the only big deal about knowing the name of it. All right, so we got an example like this, 6x squared minus 13xy plus 5y squared. And of course, first thought is going to be, say it if you know it, factor out common factors first. Again, that's got to be our first thought all the time. Factor out common factors first. Well, here's what ends up happening, and this is the key to everything here with this kind. Not only does the front term produce more than one set of possible factors, and I should say not only does the front term possibly produce more than one set of possible factors. I should have had there possibly. Again, first edition here of our notes. It can cause the placement of the back factors to matter. And that's the big deal here as well. So there's two parts. Depending upon the front number, it can cause you to have more than one possible set of parentheses. But in either case, it almost always causes you to look at where you place the back factors, because it matters. All the ones we did in the last homework section, it didn't matter if we had x minus 3, x plus 5, or x plus 5, x minus 3. That didn't matter. As long as we used plus 5 and minus 3, it didn't matter whether we had the plus 5 in the front and minus 3 in the back, or the minus 3 in the front, plus 5 in the back. It wouldn't matter. Well, in these, it's going to matter. And that's what we've got to be careful about. So here's what it ends up doing. It gives you more possibilities, and so you got to be careful. There are just simply more possibilities. So don't be so quick to write prime. Be looking for that right combination. Be looking for the correct combination. That's what you got to do. All right, best thing to do is do them by example. So here's our first example. And I gave you a running thought process down the right-hand side. So when you come against a problem like A, first thought is, hey, can I factor out common factors? So you look at it. Are there any common factors in that trinomial? Yes or no? No. All right, so, but you looked. You looked, you looked, you looked. You always got to look. Okay, so now in this situation, we need to make two sets of parentheses. And the reason we're making two sets is that front number is a 6. So somebody tell me, what are the possible factors in the front? John, give me one set of possible front factors. Okay, well, 2 times 3 isn't 6x squared. Correct. So John says a 2x times a 3x. Okay, that's one possible pair of factors, a 2x times a 3x. But what's the other possibility? Justin? 6x times x. Now again, technically you could say, how about like a 6x squared times 1 or a 3x squared times a 2? Usually not. That would be a rare situation. So here's the second possibility, 6x times x. You see now how I have two sets of two parentheses to possibly work off of? So I got to be careful. Hey, look, here's what I see with students, and I see it all the time. In all these years of teaching math, this is what I see. Students get locked into one of the possibilities only, and they'll try all of the combinations in that one possibility, and they forget the other front possibility, and therefore they say it's already prime, and it's not. My advice to the students, whenever there's multiple front possibilities, is to write out from the beginning both sets of possibilities. Now, it could be 3 or 4, but we're usually not going to give them to you. You know why? We don't want to drive you crazy. Okay? Rarely will we give you a 12 in the front, because we don't want you to have to say 12x times 1x, 3x times 4x, 2x times 6x. Now you got 3 sets of parentheses, and that would be true. And now you got so many possibilities, it's just too time consuming. It's possible, but we're usually not going to drive you crazy like that. But 2 sets, yeah, we're going to give you those, because we want to make sure, Quinn, that you know the concept. Okay? So again, what is my advice? Look, in all these years of teaching, I'm just telling you, don't do this. But the students that write both possibilities right off the bat are the ones that usually find the right pair. And I'm just telling you, from all my years of teaching this, the students that do not write the 2 possibilities right off the bat, about 70% of the time they don't get it right. About 70% of the time they don't get it right. So it's a simple little thing. It just takes, what, 4 seconds, 5 seconds to write that second set of parentheses so it's in your mind. Because look, here's what's going to happen. You're going to start doing the problem. You're working through these combinations in your head. You're not getting anywhere. And by the time you're done, you're going to even forget there's another set of front possibilities. Will that always happen? No. Is this the safest way? It is the safest way. Okay. Well, remember, we're dealing with back factors. Thankfully, in this one, there's only one set of possible back factors. 5y times y, right? That's the only possibility. A positive 5y times a positive 1y. So that makes life easier. Now remember, what are you after? A negative 13xy in the middle. So don't write this again. Let me just remind you how I think through these. Here's what I'm doing. I'm looking at my front, and I'm thinking what I'm going to put in the back. And I'm thinking about what value that gives me. Then I'm taking the other possibility and putting it in the middle and thinking what that gives me. But on these, if that doesn't give me what I want, I'm going to switch too. Because again, the placement matters. Because the front's a 2 and the back's a 3, it gives you different values. All right, let me give you a minute or two. See if you can cycle through and find the correct factorization. This does factor. We missed one other set of back factors. So we better get those out there, otherwise you guys are going to be pretty frustrated. What's the other set of back factors? There are 2 actually. Zach? Not, say again? Not a 5y times negative y. Matt? A negative 5y times a negative y. Again, that back is positive. So it could be positive times positive or negative times negative. Yeah, I better tell you that, or you guys are going to be frustrated. All right, so let me show you one other thing that you can be aware of that will always be the case in this scenario. If you guys look at the board here, whenever the back term is a positive and the middle term is a negative, there's only one way for it to work, It's got to be the negatives times the negatives. It's the only way to get a negative in the middle. So if you know that, you'd say, hey, really, I only have a negative 5y and a negative y. But again, where I put them matters. Who wants to give me what they think is the correct answer? Kyle?
2x minus y and 3x minus 5y.
All right, so let's check out Kyle's choice. Outer times outer is a negative 10xy. Inner times inner is a negative 3xy. Does that equal our middle of negative 13xy? Yes, it does. That's the correct pair. That is the correct factorization. How many got that right? And the rest of you, again, what are you thinking? You know, the 5 and the 1, their position matters. So you just can't dismiss the negative 5 and the negative 1 because you put the negative 5 in the front and the negative 1 in the back. It gives you a different value because the front is a 2x of the one and a 3x of the other. The position matters. You guys see that? Hey, put the negative 5 in the front and the 1 in the back. Now you have a negative 2 and a negative 15. That's a negative 17. That doesn't work. The only time the negative 5 and the negative 1 work is when the negative 1 is in the front and the negative 5 is in the back. And that's what I'm trying to tell you. That's what it says. It can cause the placement of the back factors to matter. You got to cycle through those choices. There wasn't that many on that one. So let's see if you guys can get better as we do some more. Let's do another one. All right, let me get higher here. Get rid of my shade. All right, so here's the second one. Factor 2x squared y minus xy minus, and that should be, yeah, that's good. All right, 2x squared y minus xy minus 3y. Go ahead and factor that. There's the breakdown on the right-hand side of what you should be thinking. Go ahead and factor that. Let me pause you guys for a second. How many factored out the common y? And the rest of you, you got to have that step. You got to show the trinomial that remains because that's the trinomial you're working off of. Okay, in this situation, you're going to make your parentheses. Don't forget your y. So that's how I would start a problem like that. Once I get to step 3, though, I'm going to say, oh, let's see, factors of the front. All right, this one, 2x and x, there's only one possibility. So we don't need a second set of parentheses on this one because the front number's a 2, and a 2 is only going to be a 2 and a 1. If it were something else, that might have 2 possibilities, yes, but this one only has 1. All right, so that's what I'm working off of. Back factors. Again, you can have a positive 1 times a negative 3. If you want to, you can start listing the other position. Negative 3 times a positive 1, because that does give you a different solution. Or you can have a negative 1 times a positive 3. And again, if you want to, you can list the different position, switching the position. Because one of those 4 hopefully are going to work in the situation of factoring this. So if you guys will just watch, because some of you, how many don't have it yet? Let me see your hands. You don't have it yet. Okay, so just stop. So I want you to think it through like I'm trying to teach you. So look, here's what I do. I'm looking at this. I'm looking right here right now. This is where my focus is. And I'm thinking 1 or 3. Okay, if I put a 3 here, I have a 2 times 3 is a 6. Is a 6 going to get me to a negative 1? The answer is no. This is what I'm thinking through. I'm doing this in my head. And I say to myself, no, I'm not going to put a 3 there. What if I put the 1 there? If I put the 1 there, now I have 2. What's my other number? A 3. Can a 2 and a 3 end up to be a negative 1? Can a 2 and a 3 end up to be negative? Yes. And my brain says, you know what? When the 3 is negative, that'll give me 3 negatives, and 2 positives, and that'll give me the middle of -1. And that's how I do them. I'm thinking it through. Front times back gives me what? All right, the other number in the middle. Okay, can that end up giving me the middle? What signs would make that work? When the back is a +1 and the middle is a -3. How many got that correct? Okay, so the pair was there. You got to figure out the right location. So you have to get to the point where you're thinking through these concepts in your head. So let's do another one. Here, we'll do this one together again so that you guys get the idea. So you're looking at C. What are you going to do right off the bat? Matt? Yeah, and what's common to this thing? What's the common factor, folks? Say it if you know it. 2. We can get a 2 out. I'm going to do a 2. That leaves me a 5n squared plus 13n minus 6. And I've always got to show that step. Okay, now I'm ready for my parentheses. I always start out with one set. And I don't write a second set unless I need it. And I won't know if I need it until I look at the front factor. All right, what's in the front of 5n squared? So that's only one choice, right? 5n times n. Do you agree? Right, just one choice. 5n times n. Okay, so I don't need a second parentheses. I'm looking at the back. It's a -6. Okay? I can have a 1 times a -6. Again, if it helps you, do the switched order. I can have a -6 times 1. I could have a -1 times 6. In the switched order, a 6 times a -1. I can have a 2 times a -3. Or the switched order, a -3 times 2. I can have a 2 times a 3, a -2 times a 3, or the switched order, a 3 times a -2. Now again, you don't need to write all those out. I'm just trying to show you what should be going on in your head. But don't miss the fact that switching the order changes what you get in the middle. And again, what are we after in the middle? A positive 13n is what we got to end up with in the middle. Now, what's going to get you to a 13? Look, can you guys watch for a second real quick? Just watch, please. Again, here's my first thought. Front times back. If I put a 6 here, what have I got already? How many? 30. And I only have a 1 left. Am I going to get anywhere near 13 with a 30 to begin with? No. So I'm saying that back is not going to be a 6. Now, I will think through the other shot. If there's a 1 here, how many do I have? 5. And if the 6 is here, how many more do I have? A possibility total of 11. Is that going to get me to a 13? No. 5 and 6 is 11. That ain't working. So you know what? I just got rid of all the 1s and 6s. They're done. I just eliminated them all. They can't give me a 13 in the middle. I only got 2s and 3s left, and I start working through them. So again, I'm trying to think. Let me stick the 3 in the back. 5 times 3 is 15. Ooh, I'm really close to 13. And what's the other number that goes with the 3? A 2. Hey, does a 15 and a 2, can that get you to 13? Yeah, if the 15 is positive and the 2 is negative. Is that one of my choices? A -2 and a +3? Oh, yeah. That's it. I just found the combination. This is the way you think it through. Otherwise, you're like Ethan the other day, and you're just taking keys out and trying every single key in the lock. That's all you're doing. You're just throwing keys out there. And all you're doing is wasting your time. You're just throwing keys out there. Let me just try this. I have no idea that it'll work. I'll just throw the numbers out there, and then I'll erase that. I'll have to do another one. I'll erase that, and I have to do another one, and then I'll write, I'm stuck. Because I have no tenacity, and I give up so easily. And then you don't learn a thing. So you don't want to do that. You don't want to do that. You want to think through the possibilities. Again, let me just be clear to you guys. The check is a positive 15n, and this is a negative 2n, and sure enough, that gives me my middle, and I know I've got the correct factorization. Okay? Outers plus inners has to give you that middle term, and that's what you got to keep in mind the whole time. You got to get to that middle. That's the process. Let's do another one. Get rid of my shade for clarity's sake. Okay, so I look at this one. Are there any common factors? Yes or no? Not on this one. Close, but there's nothing that goes to all three terms. So there's no common factors. So next, I always start with one set of parentheses. And the front number determines whether I need more than one. Hey, the front's got to be a 3A and an A, so that's only one possibility, 3A and an A. The back, thankfully, it's only a negative 2. Good. I can have negative 2b times b. Remember, the order matters, so I could have a b times a negative 2b. Or I can have a positive 2b times a negative b. Or switch that order, negative b times a positive 2b. There's only 4 possibilities. In class, what do I keep in mind the whole time? What am I shooting for? Say it if you know it. A positive 3AB. That has to be in your brain, guys. That's what we're shooting for. The middle term. You got to be shooting for the middle. That's what factoring's all about. Shooting for the middle. All right, for time's sake, I got to go quick here. So what do we have? 2 and 1. 2 and 1. So what do we got here? 6 and 1. That's not going to get me a 3, is it? No way, no shape, no how. 1 and 2. A 3 and a 2. Is that going to get me to 3? Isn't that it? Whether they're positives and negatives doesn't matter. There's no way a 3 and a 2 gets me to 3, and there's no way a 6 and a 1 gets me to 3. This is one of those rare prime ones. But I checked. And look, it didn't take me long to check. It didn't take me long. Does every number factor? 17 factor? No. 23 factor? No. Is 47 factor? No. Not every number factors, not every trinomial factor. But we looked, we tried. And it didn't take forever. All right, last one. So here's one more of those double possibilities. Are there common factors? No. Nothing is common to all three. So how do I start with 2 parentheses? So watch on this one. So now I say, oh, wait a minute, the front can be a 4x times an x, or the front can be 2x times 2x. At that point, I then put my second set of parentheses up there, because I want to see both. Right? So now go through them with your red. Do a 4x and an x. That's one possibility. Do 2x and 2x. That's the other possibility. So look, to make life a little simplistic and not show you the different positions, again, with a negative 3, you have a positive 1 times a negative 3, or you have a negative 1 times a positive 3. You can switch the placement, right? But those are the only real possibilities. Now you're going to work your way through and try to get what in the middle, folks? Say it if you know it. What are you shooting for in the middle? 12x, a positive 12x. And you got to keep that in mind. That's the whole key of what you're doing. What will give me that positive 12x in the middle? All right, you got a couple minutes. See if you can find it. You got a couple minutes. See if you can find it. All right, so last minute or two here. Again, we changed that middle to an 11x. And so again, you're just thinking through your possibilities. When I stick a 3 there, I'm thinking I got 12. And the 1 in there, can a 12 and a 1 give you an 11? Yeah, and a positive 11 would be if you had positive 12 and negative 1, right? And that is the factorization of that last one. All right, you need to practice. Hey, how many of you guys do? Anybody do Sudoku? Anybody do those? Were you real good in the beginning? Not so hot, right? You're way better than you were in the beginning. You think about any game you play. Are you that good in the beginning?
No.
You get better as you do them. Hey, that's what happens here. You're going to get better as you do them.